Hey everybody, welcome back to another episode of Aptera Reboot. Today we get to watch the Aerodynamics, Composites, and Vehicle Safety webinar. The webinar is being moderated by Sarah Hardwick. She is the head of marketing at Aptera, and today's guest is Nathan Armstrong, who is the Aptera Motors CTO. They go over quite a bit of information on this one. They go over a lot of details as far as what they're doing in the background to make sure that the Aptera is as aerodynamic as possible, as well as safe as possible. And I think you're going to be very surprised by the information in this webinar, is how Aptera is handmade, but still very fast to produce at a low cost. They go over vehicle stability and how Aptera performs in strong headwinds as well as strong crosswinds. Also, Nathan goes over how the Aptera has performed on the tracks. They recently took the Aptera to a local track in San Diego and performed some moves test on it as well, so we should be seeing that fairly soon. We also get some preliminary information regarding the strength of the composites, beating records on roof crush strength, as well as side impact and some other tests. Something they mentioned that was very interesting to me was how the Aptera can get into a crash at up to 45 miles an hour without incurring any damage in the passenger cabin. However, we don't know the details of those tests and we won't know about them until they've published their findings. They also go over the durability of the Aptera and how it's designed essentially to last for generations. Something else I found pretty interesting was that there is a team at Aptera looking at adjustable suspensions for off-roading as well as high-speed performance. We also got more information regarding the production schedule, what they're looking to produce by the end of the summer, and where they're looking to be by the end of the year. There was a very strong focus on safety, and Nathan highlighted how Aptera's goal is to meet all standard specifications for a passenger vehicle. They're also looking at additional steps that can be taken to reduce the weight of the Aptera, which is already extremely light, by replacing the glass windshields with polycarbonates. And something else that was very noteworthy is how quiet the Aptera rides. Because it is extremely aerodynamic, there's less wind turbulence, making less noise. And because it has a monocoque structure, there are fewer gaps for additional wind-related noises. And according to Nathan and Sarah, the Aptera is one of the quietest vehicles they've ever ridden inside of. Before we continue, I would like to ask you to please hit that like button, hit the subscribe button, and hit the notification bell. And leave some comments below. Let me know what you think about this. Also, I just created some new design for the Aptera Reboot store, so I hope you guys will take a minute and check that out. And visit us on Patreon. Your support is greatly appreciated. The webinar is about an hour, so sit back, relax, and enjoy the show.
Okay, well, I think we have a good amount of participants here. Still quite a few coming on. It's exciting. We'll just let a few more people come on. We'll give everyone about 1 minute. Okay. Well, thank you everyone so much for joining us today. I'm Sarah Hardwick, Aptera's Chief Marketing Officer, and I'm pleased to be here today to introduce our Chief Technology Officer, Nathan Armstrong. But before we begin, we just have too much exciting stuff happening here at Aptera. I would love to share just a few quick updates with you. We've had so much cool stuff that's happening. Just a few highlights to start off our presentation today. So we are not there yet, but we are quickly approaching 10,000 reservation holders, which is just absolutely an incredible number for us. We are so amazed and appreciative of all the outpouring of support that we've been seeing. We also have 150 plus brand ambassadors who are joining us from countries. We have actually now 84 countries around the world who have reservation holders. It's so exciting. And while the pandemic has definitely impacted some companies that are within our supply chain, we are absolutely still on target to deliver our first vehicles by the end of the year. And a couple other exciting points of note, if you haven't watched our original launch video, it actually has over 1.3 million organic views on YouTube. And if you didn't see us in the climate change section of the Washington Post, make sure that you have a chance to check us out. And coming up soon, we have some great announcements. We'll be launching a new website. And for all of you reservation holders, it will allow you to configure your vehicle in real time and find out more about your Aptera, see when your Aptera will be estimated to be delivered, and all sorts of other exciting, cool features on our website there. And then lastly, we do intend to continue to open up a new round of investment opportunity in the coming months, and we'll be sharing more with that shortly. So our topic for today is aerodynamics. And why is aerodynamics so important? Well, it is the key to efficiency. So as you guys know, our founders have been focused ruthlessly on efficiency from the very beginning. And so these are some cool pictures from a very long time ago, as you can see by our young and handsome founders there. They were actually focused and really driven towards our mission of efficiency, the entire reason for starting Aptera. And their vision, which is what we're really on a path to achieving now, is to create a fleet of vehicles that are not only efficient, but lightweight, safe, and fun to drive, which is pretty much what we've done. We are so excited. We're so close to achieving our goal. This is an image of last week from Aptera being tested at the track, which was, for myself personally, I actually had the chance to take Aptera for a test drive. And it was, honestly, guys, it was unlike anything that I have ever experienced. It was so cool. It was just really thrilling. And I can't wait for all of you guys out there to have that same feeling. So no one knows that feeling better than Nathan Armstrong, who is our Chief Technology Officer. He has been around since the beginning. And he has seen that evolution of the company. So we're going to be hearing a little bit from him. He has some great experience. He's a mechanical engineer. He's worked with some of the top EV brands in the industry, and he actually was an engineer on the International Space Station. So Nathan's going to be leading us in a discussion today about some key areas of our vehicle, including Aptera's ability to be lightweight, aerodynamic, our composites, and then also safety. So we will be doing a live Q&A afterwards, so feel free to pop your questions in the chat there. But at this point, I'm going to start sharing, and I'm going to let Nathan take it away.
All right. Well, hello, everybody out there. Hello, Mom. Thank you, Sarah. Was it better than chocolate was one of the questions there. I think we should just dive into that one, Sarah.
I think, why don't you just go ahead and start and just tell us a little.
Sure. Yes, it is better than chocolate. So today we're talking about aerodynamics, we're talking about safety, we're talking about composites, and we're talking about the goal to strive for perfection in efficiency. So you want to start with aerodynamics? So I guess, as everybody kind of knows, I mean, one of the goals of Aptera from the very beginning was to demonstrate like an extreme in aerodynamics, right? So the most aerodynamic shape possible while containing two people safely was the original ethos. And when we started looking at the numbers, and the original shape came from Steve's kind of vision of a shark swimming on the ocean floor, was where the original kind of shape came from. And when we started running simulations on the shape way back in 2006, 2005, we realized that the net gain that we were seeing over like current vehicles was such a paradigm shift in efficiency that they really drove the program forwards, because we were as aerodynamic as the windshield wipers on a pickup truck at the time. And one of the references was the same as a 12-inch cube driving down the street. And when you compare that to a current vehicle, you realize that we really, there's a huge amount of gains to be had in the design of vehicles still. So that was really one of the original drivers that kept us to keep going down this path of trying to get the ultimate aerodynamic shape while keeping you safely going down the road. So.
That's great. I think we can just, are there specifics you want to talk about, Nathan? I can just kind of dive into some of the questions, but I think I know kind of one question specifically just that popped up and I saw a couple times already is stability. So can you talk a little bit, speak a little bit more about kind of aerodynamics and stability specifically?
Well, stability when it comes to aerodynamics is, it works in our favor in all cases. Side wings, headwind, any kind of like wind obviously just blows around the vehicle because of the shape of the vehicle. So we're not subject to the same kind of crosswind forces as most vehicles. But stability is mostly based on where your mass is placed. And in a three-wheel vehicle, there's well-known equations how you achieve this. A little bit of stability control in there, and you basically got a very, very stable vehicle. It's an analogy to the three-legged bar stool kind of a thing. It's no less stable than a four-legged bar stool. So the current vehicle out of the drag strip doing the moose test and doing all the tests is performing great. So stability-wise, I mean, it's a really strong platform, and it feels very stable. Like when you drive the car, it doesn't feel like driving a three-wheeler. It feels like driving a just kind of an interesting normal car. So.
So one of the questions, I'm going to put my video on here. One of the questions that we see here is specific to counter efficiency. Specifically, let's see, we're asking these some great specific technical questions, but talking about the body strength specific to the roof. Is the body strength, would the body strength be enough to get rid of the roof is one question that just came through.
No, it wouldn't. No, the whole vehicle is basically like a motorcycle helmet. It's a one big stressed skin composite monocoque that we fill with foam, and the whole thing becomes a structural unit at the end of the assembly. And the roof is definitely integral into keeping that whole thing stiff.
Yeah. Maybe I think just kind of the key areas that we talked about that you were going to dive into. Why don't we talk a little bit just about like Aptera's ability to be lightweight, so lightweight yet strong. So tell us a little bit more about, how can this be achieved? We've heard about Formula One race cars. We've heard a little bit about, all these aerodynamics. So tell us about how it's possible for Aptera to be so lightweight yet so strong.
So that all came from developments in the composite industry that happened during the mid-90s, early 2000s. When vacuum resin infusion and high performance resins started coming into the market, and composites took a really big leap in what they were able to do, and especially on the production side. Like a whole bunch of new techniques were kind of invented and brought into the market that really gave composites the jump from like hot tubs and like that kind of shower stall thing to like high performance composites. Not quite aerospace level, we're not talking autoclave level, we're talking still vacuum resin infusion, but still the performance here was so close to where aerospace was that we were able to get super high performance composites with relatively low upfront investment compared to typical aircraft tooling. So that really gave us the ability to design structures that we weren't able to before. And the goal of these structures was primarily safety. Because composite structure isn't like a metal structure. When it's impacted, it caves in, absorbs the energy, but then goes back to its original shape. And we saw this on the very first car when we tested the roof crush, and we pushed it down with a hydraulic ram, and we took the ram off, and the whole roof just went pop, and like popped back to its original shape. And we all just, it was one of those moments when you're like, this is a huge paradigm shift in safety, because if we can tailor the composite to absorb the energy how and where we want it to, and then return to its original shape, we've got a massive gain in safety. So that was a primary factor. And the lightweightness of composites just comes, it's like a byproduct almost, just through the nature of the material and how you do the construction. You went with very lightweight structures, but extremely safe, like so safe, like we just couldn't believe it when we were doing the original tests. Like I think we beat every world record for roof crush test and side impact test and everything. Again, it was one of those things early on in the program that spurred us to continue down this path of really perfecting the composites and the structure of the vehicle.
Can you tell us, Nathan, what is the actual weight of the vehicle?
I think the body tub itself, the structure itself, is 190 pounds. And then the vehicle fully built out is less than 1,800 at the minute. But we're trying to get it a little bit lower than that. We're trying to get it down to, as low as we can kind of thing. But it's still extremely lightweight. And one of the interesting things we're playing around with now is that because we've got in-wheel motors, and there's a question down here about sprung and unsprung weight, because we've got more sprung weight now and less unsprung weight, we're having to do very clever things with suspension design and spring design, that kind of stuff to compensate. But the in-wheel motor is going to be a very interesting thing for people to experience and to drive a vehicle with in-wheel motors, because the torque application it feels different than a normal car, and it's going to be exciting for people to drive an in-wheel motor vehicle. I think it's going to be a paradigm shift as well.
Thank you. One question that came in: at what speed does aerodynamics become significant?
35, 45 miles an hour, somewhere in there. 55, it becomes significant. 65, it really makes a difference. 85, it's massive. Anything below 35, it's still significant, but it's not as significant.
Yeah. Okay, great. What materials, can you give a little more on the materials of the composites that our production vehicles will be made of? I know you may have some samples hiding back there, some visual displays that you might be able to show us there.
I do, yeah. No, it's this is an interesting part of the project, because when you start talking about epoxy-based composites, you start talking about things that potentially could last indefinitely, like literally, hundreds and hundreds and hundreds of years, kind of thing. Within the company, part of the deep-rooted philosophy is that we want to make things that last as long as we possibly can. Like, we would love these Apteras be passed down to people's grandchildren, and basically just refreshed and upgraded over time, kind of thing. But there's no reason. I mean, the body is hail-proof, it's dent-proof. I mean, there's no reason it should ever degrade. So the main body itself is just glass fiber reinforced epoxy. There's nothing really magic about it. What is special is that the epoxies now are way more high performance than they were 5-10 years ago. And the fiberglass is the same as it has been, but it's still good material. Like on the Boeing 787, it's still used on the wing nacelles for the flexibility of the wings. But how we design the parts, bond them together, do the foam fill, and build the structure with the fiberglass is really the secret sauce. So that's the body. And then the interior and the exterior panels that we're expecting to have to be replaced over time. So panels that are going to get damaged and need to get replaced. This is where this stuff comes in. So this is the accumulation of 14 years' work to develop a natural fiber composite material. And this is a hemp material. It's grown in Canada, it's processed in Europe, and then we bring it back here for manufacturing. But this is 100% natural, obviously. Required no processing to get to this point, apart from 1,000-year-old technology to remove the fiber of the plant and weave it using, again, 1,000-year-old technology. But what we're finding is that when you configure natural fibers in a manner like you would a regular composite, the strength benefits are incredible. So we're seeing that this actually is becoming a more high-performance material than we were expecting. And the long-term vision is there are resins on the market now that act like epoxy resins, that have the same performance as epoxy resins, but are 100% natural material-based and are 100% biodegradable. So they last above ground indefinitely until you bury them, and then they basically just dissolve. So if we had a natural fiber-based composite with a resin that was biodegradable, we would have high-performance parts that would be 100% natural and biodegradable. So we're thinking that the replacement panels, interior panels, parts that are not so structural can be used out of this material and be designed to be replaced. And then the main body itself will be designed to last indefinitely, kind of thing. So the natural fiber composites is very exciting for us. It's an area I think we're going to demonstrate that. Like it's been done before, like the BMW i3 used it on the dashboard, but it was just a pad, it wasn't structural. And we're saying that we think we can actually now make semi-structural panels from the natural fiber material. We wouldn't go full structure, but like this accent, like the outside panels could be possibly just made from natural fiber. So that's for me personally is like, that's huge. That's a great one. So yeah.
That's great. Thank you so much. So in regards to our composites, can you talk a little bit about, in the event of a collision, are there designed crumple zones? How do the composites behave in that type of situation?
Well, of course, we've got 6 or 7 different scenarios that we have to look at. We go front, side, rollover, rear 3/4, front 3/4. And in every scenario, the vehicle is designed to absorb the impact in a specific way. And again, because of composites, like with metal, you can't tailor metal specifically down to well, you can get down to the grain structure, but not really. Like you can get down to wall thicknesses and ribs, that kind of stuff. With composites, you can literally place the fiber specifically where you want to see the loads transmitted to. And you can tailor it to flex in one direction or not another. You can do all sorts of things with it. So the body is designed to absorb impact in every scenario that we can imagine. And then, like we say, return back to its original form. Which is massive. The front of the vehicle has a metal subframe. So we have the composite tub stops at the firewall. There's a metal subframe in front. That whole thing is designed to collapse, absorb energy, and before it gets into the passenger compartment. And in a normal 45-mile-an-hour collision, the passenger compartment shouldn't get damaged at all. Like that should be completely savable for the next, just change the front end. Side impact is great. Rollover, like I say, we're at like 6 times vehicle weight on the last vehicle test we did. So rollover, I think the vehicle probably won't do anything. So anyway, we're excited to test this new body structure. We've improved it a lot over the last vehicle. There's more roof structure. We've eliminated some metal that we had in the very first car that we didn't like, so we got rid of that. And we've got full composite now, and pretty soon we're going to be building the jig again and crushing the things and seeing what kind of results we get this time. But if it's anything like the first car again, it's going to be record-setting performance.
Thank you. Thank you. Couple of questions here regarding, and this is just kind of taking a step back, but the aerodynamic shape. How does that impact kind of the classification of Aptera? How do you see Aptera in the landscape of other vehicles? Is one of the questions here. So where do we fit?
Classification-wise, well, it's an autocycle in the US, as we know, right? So it's a motorcycle essentially, but autocycle is one of these interesting classifications that are kind of in between. So if that's the question, it was just we're autocycle.
Yeah. I think that's probably enough for right now. We have quite a few of our fans online today who are interested in the camping package, the off-road package, and wondering how that might potentially impact aerodynamics. Is there anything that you can speak around our plans for that and how that might potentially influence the aerodynamics of the vehicle?
Well, I don't know how much I can say on that. There is a conversation happening and a team looking at doing adaptive suspension, like adaptive height suspension, right? So, I mean, airbag would be one way, mechanical, you do another way. But for the camping package, the off-road package, the thought is that you actually could raise the vehicle a couple of inches, right? So that would be something there. And then if we had that suspension, you could also lower the vehicle at high speeds. Right, so that would be something else that we're investigating that we're not putting out there yet. Like, it's a very expensive package to do that, and overall in the cost of the vehicle, it'd be quite an impact. But if we could have adaptive suspension, of course, for off-roading, that would be neat. So, but of course, the vehicle is so light, and if you've got 3-wheel drive, it's going to be tremendously capable off-road. Strangely enough, like I bet we'll see some people off-roading these things and doing crazy things with them, right? So.
Yeah, and I think that brings up a good point. There have been a couple questions asking how far along are we in testing? How finalized are we? Have we received all of the correct certifications? And so maybe if you can just explain a little bit, where we're at, because we are at a point where we're testing a lot of things, looking at it, doing a lot of analysis, looking at how things are impacting aerodynamics. So can you kind of explain a little bit where we're at? And that does leave some room open for some potential changes to be made to the vehicle, probably or potentially before we even take it to market. So any thought on that?
Well, as you know, the state of the vehicle at the moment is the black one that you see around at the moment. There's a whole series of vehicles being built based on that design, which is a design we started back in 2019. Since we evaluated that vehicle and did the testing on that vehicle, we've made some changes to the body. We've made a bit more room for batteries, made a bit more room for the occupants. We've actually improved the aerodynamics slightly, which was a huge thing for us. But that new design is now going into, it's already into the production engineering cycle. We are a decent ways through that. We're going to be releasing tools in the next month. We're going to be hustling to make probably 10 vehicles through the summer, and then they go into testing, and we've got all sorts of testing planned. And then by the end of the year, like everyone knows, we're hoping to have the design stable. We're hoping to have the prototypes finished. We're hoping to have certification in place. And we're hoping to get going on production beginning of next year kind of thing. So as far as certification, I believe everything is understood for the US. I think all certification-wise, we're good. We're aiming to meet all certification for passenger vehicle specifications, which is a fairly lofty goal. There are some things that we're trying, like we might be looking at polycarbonate windows to save weight, which isn't actually something, I don't think it's allowed in automotive at the minute, but it is allowed in a motorcycle. So we might be using the motorcycle regulations to our advantage if we can save weight, obviously without reducing safety, but that would be an area that if we could save weight, we would. So like I say, we're trying to meet passenger vehicle specifications, safety specifications,
Great.
Yeah.
We have a lot of technical questions specifically around the composite. So someone's asking about the epoxy resin. How does that epoxy resin, how long does it take to cure, and how does that affect the ability of our vehicle to move into production?
Oh, goodness. Well, there's UV cure epoxy, which basically uses like a dentist thing, which flashes UV light and it cures in a few minutes. We're working with a group that have a flash cure system where the turnaround time is 3 to 5 minutes per part in the tool. So, we have to be in that kind of range. Typically automotive, you want a part per minute. Our takt time is a bit longer, so if we have a part per 5 minutes, like we're probably fine kind of thing, but that's our goal for all the turnaround on these tools. So it's very exciting.
Yeah. Okay. One question was in response to your statement that we form the shell using similar methods as fiberglass boat hull production. So these can be expensive to repair. Can you talk a little bit about how, repairability of our composite shell? How will that work?
It sort of isn't. It's sort of like you could, right? Like you could repair the body, but it's kind of like a motorcycle helmet. Right, like once you've cracked it with a composite structure, you really don't know what internal damage you have. So you typically just replace the helmet. The monocoque of the vehicle, like I say, it's not complicated. To tear a vehicle down and rebuild it can be done in a few hours. So if you did damage your monocoque, the idea would be you would just replace it. You keep all the good parts on your vehicle and you just put them on a new monocoque. That would be the way.
Another question around the long life expectancy of the body. So given that we expect it to last, a significant time, is our body cavity that holds the battery package designed to accommodate future battery configurations as that technology evolves?
Oh my goodness, yeah. I mean, we're seeing battery technology now. The big gains that we're seeing is in size, like density versus size. So the battery pack we have now is the biggest, I think, that we're ever going to need it to be. And it's so big right now. It's crazy. The whole belly of the car is all batteries, and it looks like with the new technology that they're talking 3 to 5 years from now, that's going to be half the size with the same density. So yeah, I think the battery is going to end up getting quite a bit smaller. Obviously, if the density improves versus to weight to size ratio, then we can just get more range with the same size battery. But at the moment, we've got enough space to pack like so many batteries. It's outrageous how they're contained all in the belly pan.
That's great. Okay, a couple questions regarding heat dissipation and the flexibility, the durability of our body over time. So can you talk a little bit about how heat acts with our composites and how it dissipates, how it potentially might impact our body structure?
Heat doesn't affect it. No, it's cured at such a high temperature that we don't even get close to that with normal everyday temperatures kind of thing. I've seen some questions about hazing, like on the polycarbonate. We're doing coatings on the polycarbonate to avoid that. We put UV inhibitors in the fiberglass resin so that it doesn't degrade over time as well. And then, of course, the goal for all these cars is going to be a paint film wrap versus like traditional kind of paint. And then the paint film as well has additional protection. And of course, if you just scratch your car, you just change the paint film then, right? That becomes part of that whole thing. So, and that comes down to kind of part of the ecological kind of footprint too. Like painting is a very dirty process, and to set up a paint plant is a real, it's not a nice thing. So the paint film and how we do that automatically and how we kind of automate the process of applying the paint film is going to be something we.
Yeah, and that's going to be an exciting thing we'll be announcing for you, our reservation holders, at some point soon. We'll be releasing what those options are, and we have some really great solutions that we have come up with for you. So we're very excited about that. Okay, question regarding opening the windows. We have a specific kind of, half window there. Can you talk a little bit about that? There are some questions regarding how that might impact the aerodynamics.
Well, that's that actually, when we first started working on this car, when you design a car, the very first thing you design is the glass drop. Right? You design a barrel so that the glass drops into the door. That's how you start a car design. And when the Aptera was designed, it was designed as an aerodynamic form primarily. And then when we were like, hey, how do we get the glass to go down? And you start looking at the because it's not a cylinder, right? It's a very complex curve to the body to it. So as the glass drops, it goes through this weird corkscrew kind of motion. It causes all sorts of headaches. So that's why we could only do half the window, right? Is because the curvature of the window would not allow the glass to drop inside the door. It just wouldn't go. So the door we have now is big enough to get a soda can through kind of thing. Drive through window would be fine kind of thing. Aerodynamically, it shouldn't make it would make some drag at high speeds, but at low speeds with the window open, we've got decent flow over the panel that it's not going to be too noisy in the car or cause too much drag kind of thing. But yeah, it was regular window, goes up and down.
Okay. Yeah. Great. Okay, now can you elaborate a little bit? I mentioned that Aptera draws inspiration from Formula One race cars. We have a special safety cell that we've engineered. Can you talk a little bit more about, where that inspiration comes from? What that means? Can you elaborate on that for one of our participants?
Well, yeah, I mean everybody's seen Formula One cars in a crash, recently, right? And everyone's seen how the tub performs, right? I mean that it's a great demonstration of what composites can do when they're designed and used properly. I mean, they're tremendously safe. Not only do they, like I say, absorb the impact and bounce back, but because they are lightweight, there's not much mass there to have to absorb the energy anyway, right? So everything works in the favor of these things being super safe. The inspiration from the composite goes back to Lotus back in the 60s with the Lotus Elise, which was the first all-composite road car, and wasn't copied until modern supercars, right? But modern supercars at the minute have kind of the niche on composite tubs and composite structures. The BMW i3 and the i8 had composite structures, so that was really a first foray of a major automaker into like a passenger vehicle with a composite structure. But again, I believe it was demonstrated very well in those vehicles. I don't think there's been any issues. So we're just kind of carrying down that path. It's an evolution from DuPont back in the 40s through where we are today with composites. And like I say, we still see a lot of low-hanging fruit. We still see a lot of improvements to be made. We're still seeing a lot of new tooling techniques coming out that people are inventing. That's quite exciting too. So yeah.
Thank you. One question is around what type of simulations are we running? And I know I've seen some really cool graphics with, showing the airflow, and we actually showed some of those really briefly during the introduction section here. So can you talk a little bit about, I know in the old days, a decade ago, it took a lot longer when you would make changes to the vehicle to look and design to see how that would impact the aerodynamics. But I understand now it's, a radically transformed process that allows us to get input, nearly immediately. So can you walk through what that process looks like?
Like if you go back to back when we did the first car, we had Miles Wheeler, who was our aerodynamicist, did the virtual study on the car. And you could do this thing where you glue little pieces of string all over the car, and you see how the strings flap. And back in the day, that's what they would do. They would glue string on the car, go drive it with another car next to it, and video what the little pieces of strings were doing. So you can run that as a virtual test in the software we have. So he ran that test, and he had one little piece of string, like by your shoulder, on the back of the car that was flapping. And we're like, that's strange. So we actually did it. We went out to the track and we glued pieces of string on the car and we drove the car. And that one little piece of string was flapping. Like the simulation was so accurate. It got down to like that level of and we were just blown away by this. With the simulation software is like so incredible. And the Aptera is such a beautiful case for the software, because software normally is challenged with very unaerodynamic cases that you're having to improve. Whereas with the Aptera, you get these beautiful laminar results, and as you adjust the simulations on the surfaces, you see how the laminar flow changes. It's just beautiful. So we're doing a whole bunch of aerodynamic simulations. Actually, they're finished now. The new body is set and everything's finished there. There's composite, crash simulations that we're doing. There's mechanical stability simulations using software called Atoms to do that. That is because all the driving forces and all that kind of simulations. The wheel motor company we're working with are running simulations as well to get us the best traction control and stability control software developed. So, yeah, but I'm a big fan of real world testing. That's what I'm excited for. To actually get some of these cars and go, do crazy things with them, and see if we can break them. So.
That is exciting. One question is around surface treatments, and have you explored any surface type treatments to increase aerodynamics, like a shark skin? I think he mentioned.
There was something about that. There was somebody came out with a film that had a nano, like a golf ball kind of a dimple thing. I think we actually tested it on the first car, and I don't think it actually made any difference. And I think on the first car too, we actually experimented with dimples on things like golf balls too. Like on the inside of the fenders, I think we had down at the very beginning. But didn't seem to make a lot of difference. The car's so efficient as it is, those little gains don't really give you a lot. So
yeah, that makes sense. Let's see. Can you talk about, this is a great question. I think one of the things that is so unique about Aptera is the fact that we only have 4 main body parts. So can you talk a little bit about how those body parts are actually attached together?
It's beautiful. We got a great system here. So essentially the heart of the structure is the floor, right? So that comes up to the firewall, it comes down to the passengers, comes up and goes all the way to almost to the back of the vehicle. And on top of that, we've got the spider. And those two pieces self-locate. They've got features that they just click together. The base is sitting in a fixture, the top clicks on, and that gets bonded as the first operation. And the second operation, the body sides come on, and then there's a few pieces that come on to kind of finish the structure, but that's essentially the whole structure, right? And that's kind of what is giving us the ability to have the price point where it is, because it is essentially a handmade vehicle, right? But we're using labor efficiently enough that we can have artisan labor essentially on our workforce and still make a profit at selling the vehicle at a decent price. So it all comes down to the simplicity of the design, the low number of components, the rapidness of assembly, and we've got a few fixtures for the assembly, but basically the body is self-fixturing. And again, if you look at like a typical car factory and the amount of fixturing and robots and jigs that's necessary, like we don't have a fraction of that. So yeah, it makes it a really enjoyable assembly process. Like it's very nice.
Thank you. Well, so a couple of questions. This is interesting. I know when I drove Aptera, one of the things that I was really surprised about is how quiet it was. It was just very quiet. There's a couple questions here about, what about the aerodynamic noise inside while driving? So can we talk a little bit about that? I think there are one or two questions regarding that.
The closest analogy I've ever seen, I've never actually been in a glider myself, but I've seen videos of guys flying glider planes. And it's the same kind of principle as that. Like there basically is no noise. Like if there's no drag and there's nothing to create turbulence, there is no noise, right? I mean, it's as simple as that. So I mean, it's the very first car that I drove back in the day. All you could hear was the motor noise, just the whine from the motor, and there was no body noise. And because it's a composite structure too, you're not subject to the same. Like on a regular car, if the spot welds don't take or something, you end up with squeaks and rattles and making all sorts of noises and stuff. And we don't have any of that. Like it's dead quiet. And the natural frequency of the composites too is much lower than a metal, so we absorb a lot of road frequencies. It's beautiful. And crosswinds, you don't even feel them. Eh? Like it's just nothing. It just blows right around the car. There was a joke years back when someone was talking about how we're not going to get any flies stuck on the front of the vehicle if you drive through a swarm of flies, except for one. Right on the front of the nose, you'll have one fly stuck, like right at the front of the vehicle. Otherwise, it just flows right over the vehicle, right? I mean, it's rain, snow, everything just flows over it. So
that was a question: how weather impacts the aerodynamics specifically.
Don't even feel it. You don't even feel it. The wind just blows right around it, right? Like it doesn't do anything.
Okay, we have a question from one participant here. Are you really claiming 1,000 miles range? This is unheard of. Yeah, Aptera has the furthest range of any vehicle that's out there today. Can you talk a little bit about how aerodynamics help us to achieve this range? Talk about how it actually empowers this breakthrough.
Well, I mean, it's I don't know how much you can get into the numbers on this, but the 1,000-mile range vehicle, we have the batteries packaged. We have it worked out where mechanically it's possible. Right. And this came from running the initial drivetrain system simulations last year. And it was Steve and Chris again. They were like, goodness, guys. They were like, look at the efficiencies we're getting. Like, if we had a battery big enough to do 1,000 miles, like, how big would it be? And we did the calculations on that and realized we could actually package that in the vehicle. It was one of those like crazy moments where you're like, is this wow, okay, well, this is interesting, right? Like and it's actually not that big of a battery. Like we're getting, because of our efficiency, we're getting the same distance on less than half of the same size battery pack in a current electric vehicle, right? So, we get a lot more work from the batteries that we have. But yeah, aerodynamics is a huge part. Lightweight, of course, is a huge part. And it's just science. Like there's no magic here. We're not saying anything's perpetual motion, anything like that. It's just, we do more with the same amount of batteries. We can do a lot more. So, yeah, I know it was incredible to think of 1,000-mile range. Like to me, as well, when we did the numbers, we're like, no way. Like, and that was a couple of years back. I think the max range on a car at that point was like 300 or 400 miles. I think that was like the big, right? At that point, I was like, wow. So yeah, very exciting. And I love that. Like for me, like I would never have to charge my car like once a week. It'd be fantastic. So
yeah. Thank you so much. Let's see. So many good questions. You guys are great. I've definitely seen a lot of questions around. I know, Nathan, you mentioned early on Aptera in Europe. Just wanted to re-emphasize for everyone, we absolutely are committed to doing everything we can to bring Aptera to Europe. We are aware that there are some, challenges in some areas regarding width, but we're definitely working on those. And so, for those of you that have been asking in the chat, regarding bringing Aptera to Europe, we're definitely working on that, and we absolutely want that to happen. We have a ton of reservation holders from Europe, and we are committed to working with you guys and doing everything we can to bring you Aptera to Europe. So wanted to answer that question right off the bat. Let's see. Can we talk? You talked a little bit about battery. I think we've got some questions around like sizing of pack and how is it possible to add battery weight without affecting the efficiency and the aerodynamics? So is there anything you want to share a little bit related to batteries and how batteries and additional battery packs might impact our aerodynamic ability?
Mm-hmm. Well, first and foremost, all the batteries are always placed in the belly pan of the vehicle. Biased forwards, obviously, right? So we're trying to get as much weight forwards as we can. So the battery pack sits under the floor, and we don't have the luxury of like a regular EV having a flat floor, obviously. So our battery pack is quite interesting. It's basically made up of a form that fits inside the center tunnel, comes out under the belly pan, and then comes around on an arc at the bottom. And these stack up in one big brick, and that whole thing goes up into the belly pan. So we're maximizing that whole volume under the floor as efficiently as possible. So it's not a normal looking battery pack. It definitely is a very strange looking pack, but we were able to cram that whole belly pan just full of batteries. And then as we increase the size of the batteries, we're only adding more weight to the same area. So we're not adding packs anywhere that's going to throw the weight off, right? So as the battery pack increases, it increases the weight, but it doesn't decrease safety or stability.
Great, thank you so much. One thing I know that we are working on, and it's again one of those things that I don't think we have absolutely made a decision on. Can you give us an update on the side cameras?
We're still working on them. Like it's still, I believe, the production intent to have cameras. I've seen a few production cars with them. I think the Polestar and a few production cars now have cameras. So I believe regulation-wise, we're allowed to do it now. I got to double check on this one, but when we first launched the car, it was illegal to have cameras as rearview mirrors, and I believe that's changed now. So
yeah, I'm not sure. I think there may actually be some challenges. I think we're potentially working through some challenges. I don't think we know anything yet, but I think we can share more. But to my knowledge, I think that is something that we're working on. I didn't know if you had any more details on that. So
obviously, it's an aerodynamic gain if we can go to cameras. A huge aerodynamic gain, so definitely that's the desired route.
Yeah, that's great. Okay, let's see. A couple of questions around, and this is less aerodynamics and more just I think the composite body. But are there specific jacking points around the vehicle? How would you change a flat tire? How will that work with the composite body structure?
Yep. So we've got 4 primary jacking points under the vehicle. That are used during the vehicle construction and for mounting the battery and for mounting the belly pan and for jacking points for the client. So we've got 4 hard points underneath the vehicle, but you can jack the vehicle from on the back of the vehicle. We have a big plenum that comes down, a big composite plenum. That is our rear bumper and also an air chamber that removes air from the battery compartment, takes it through the plenum and dumps it out the back under the skirt. That whole piece you can jack on as well. You put a jack around the thing, lift the whole car. There's only 600 or 700 pounds on the back of the vehicle, so 2 big guys could lift the back up, no problem. And in the front, we've got jacking points for the front, so that's all been considered, and yeah, should be fine. We should be able to put it on a standard shop lift. It's kind of the core, right? So.
Okay, another question, 2 wheels versus 3 wheels. Can you talk about stability, control, impact on aerodynamics? We have all-wheel drive, which is amazing, but you can also have 2-wheel drive. So can you talk a little bit about, there's some questions around kind of the difference and how that might impact performance?
I mean, fundamentally, it's rolling resistance was a part of it. That's a very big drag loss on vehicles. So going to 3 wheels, obviously you have a quarter less rolling resistance, right? So that was one big aspect of doing 3 wheels. Obviously for a vehicle that was intended to demonstrate like an extreme, which is kind of what this vehicle was. It was demonstrated. It was designed to kind of be like this is as far as we can take it, right? This is as far as we can take practically a super efficient design. And then once we establish this kind of milestone, we build from there, and we come up with like the less radical vehicles using the same lightweight, super aerodynamic kind of philosophies. But this vehicle really is a statement vehicle. So on this vehicle, we wanted to make it as efficient as possible. And that was really the drive of the three wheels. Was it's just a little bit more efficient than four wheels. With four wheels, because they line up, the aerodynamic drag between the wheels isn't that great. So actually, like the front wheel kind of shadows the rear wheel. So you don't take much of a hit there. But rolling loss, you take quite a big hit. So again, this vehicle that's why it's called the Paradigm, right? That's such a fantastic name. He came up with that, Sarah. But yeah, wonderful. But it really is that's what it represents. It represents a paradigm shift in thinking and demonstrating what like a vehicle can be. Right?
Yeah, I mean, when you start with efficiency, I think what we're showing is that anything is possible, and it's really exciting to hear from you and hear all of these advancements. I do have a couple more questions, so I'm going to keep going for the next 15 minutes at least. So. This is a good question. It's kind of a forward-thinking question, and I think there are some people saying, this is all great, but you guys, there's got to be some challenges. You have this huge goal of, bringing these vehicles to market. You want to bring vehicles to market by the end of the year. So, what does the Aptera CTO group and Aptera in general really need the most at this time? So I can certainly answer that from my marketing perspective, but what do you need, Nathan? Like, how can is there anything that the group that's on, we have hundreds of people, 563 people on this call right now who would probably be excited to help. So is there anything that they can do aside from getting out there and, sharing about Aptera and helping us to kind of start our movement? Any thoughts on that from your perspective? More HR resources, they suggested. We are going to be growing our team significantly over the year.
Yeah. Well, I have noticed, after doing a few of these kind of podcast things, that the questions are actually technically very astute, and a lot of good points are being raised. And obviously, a lot of people, interested in the project that have aeronautical engineering, aerodynamic backgrounds, and a lot of really good suggestions keep coming up, right? So, I mean, if there's a way that we could capture those suggestions and then give the folks, reward for their suggestions, I mean, that would be wonderful. I mean. Why not employ the minds of 2,000 people if you can, right? I mean, right? So so just on this chat now, there's been so many good ideas popped up. I was like, goodness, so yeah. I mean, if we can get people just suggesting things that they can think of that would, from an engineering perspective, help, I would be very interested in that. And of course, if you want to put your grubbies on and come out and make some cars, I mean, that would be the other thing too. So.
Well, we have lots of volunteers for test drives. I've been seeing who have popped in the chat here. So that is something, as we have more development vehicles and more marketing vehicles available, we will be doing events in specific markets. We will be doing meet and greets. We'll hopefully be doing some test drives. So, as we have more of have Seoul coming to down to San Diego soon. So we'll have our second vehicle ready. And as that happens, we'll definitely have more opportunities for all of you out there to get an up close and personal view of Aptera. So that will certainly happen. Lots of volunteers that I've seen popping up here. Okay, let's see. There's a little bit of a discussion happening here around polycarbonates versus glass, and a little bit like no glass, all glass. What about polycarbonate? So anything you want a little bit of a debate happening in the chat. Any light that you can shed on this?
Yeah, so polycarbonate typically isn't a great material. It yellows and hazes, and it actually isn't approved for automotive. Like, as far as I know, I believe automotive has to be glass. And like I said before, because we're autocycle, we have the opportunity to use polycarbonate if it's a good production solution. So we're working with a couple of companies now that have a protective film that goes over the polycarbonate that supposedly gives it scratch resistance, UV resistance, and makes it a decent kind of product that's going to last. We still have to investigate that. But if it's true and the testing works out, then we'll be saving quite a bit of weight, especially on the rear hatch glass, because that's a large piece of glass. So yeah.
Okay, so with three wheels, it's difficult to miss obstacles. So how is it possible for people to absorb potholes? Will the tires have enough sidewall to avoid debris?
Yeah, no, we're not going with a very low sidewall. We're going with a reasonably sized sidewall so that we can take impacts. The rear suspension is very robust. So mechanically it can take anything. And then the skirt area, we've actually designed the front of the skirt and the rear of the skirt have a replaceable bumper. So it's going to be like a molded foam or some kind of sacrificial element. So if you do hit a really good pothole with a rear skirt and you bash the skirt, it's just going to be a matter of taking the front piece off and changing that front piece. So
okay, we're moving fast and furious here. Two questions regarding suspension. So will the suspension system have a dynamic camber for banking and turns?
Ooh, oh, don't I wish? No, not at this point. No, it's standard. I mean, it's long wishbone front suspension, so it does kind of get more into like Formula One style geometries. And we got fairly nice. Our suspension's great. We've got great camber game. We've got great scrub. Like everything's really nice from the geometry of the front suspension wise. You can see on the vehicle, on the picture behind you, we've got the double lower A-arm. So at that time, we had to go to a virtual lower ball joint, sorry, because we couldn't package the ball joint inside the motor. That's been changed now, so we can go to a traditional lower A-arm. So we're making advancements in the suspension. And there's a question there about the wires hanging down as well. And that's just very early prototype stuff. The next vehicle, all those wires are tucked up into the airfoil. Everything's all tucked up, so it's not creating any drag.
Okay. So are those metal suspension parts cast or 3D printed?
Oh my goodness, we tried to 3D print them. We really tried. The state of the industry on large scale metal 3D printing is still almost prohibitively expensive. It works, but oh my goodness, the cost is outrageous. It's outrageous. So at this point, we're sandcasting and then doing traditional kind of post machining. We've got tubular structures we're investigating, and then just billet machine structures that we have as well. So we're just going through kind of how we work out what it's going to be at the end. So, but yeah, it'll be traditional, cast aluminum stuff.
Okay. So this is like a bigger question. Why do you think there is a near vacuum in America for efficient all-electric vehicles? That's what we do. Why aren't there more companies?
We've been saying this for years, haven't we? We've been saying this for years. Why is nobody else realize yet that there's such a huge net gain to be made in efficiency? Huge. The cars we're driving now are outrageously inefficient. I mean, you can look at history. You can just look at how cycles work, right? If you get a job at a car company, you inherit a platform, you're going to do a redesign. The reason cars keep getting bigger is because each engineering team is harder to make a car smaller, but it's easier to just keep adding to it. So as cars evolve, they continue to keep getting bigger and bigger and bigger. And we seem to have gotten in a vicious cycle where we're not able to kind of rethink why we're doing things and kind of pause for a second and just kind of stop and look at why we're doing things the way that we're doing them. And that really, to me, was what Aptera was when Steve and Chris first came out with this thing. It was a demonstration of just how kind of old fashioned the rest of the industry thinking is, right? When you look at it from an aeronautical perspective, Steve was a pilot, right? So he comes at it from an aeronautical kind of perspective, thinking about airplanes, how airplanes work. Chris came at it from a composites perspective, thinking about how you build composite stuff. And when they came together, I mean, it was just dynamite. And I think, me personally, it opened my mind to what was possible. And, I think with this vehicle, we're going to open more minds to what's possible and hopefully maybe fill this vacuum a bit, right? Because people don't know what they don't know. They don't know that it's possible to have a vehicle that's half the weight, 10 times better aerodynamically and 10 times safer than what they're driving now. And one thing we haven't talked about yet is how beautiful it is, right? This is something that until you see the vehicle in person, you really don't understand how breathtakingly beautiful this car is, right? So we're actually designing for a more attractive, more beautiful future, at the same time, more intelligent use of materials, more intelligent use of batteries, everything, right? I'm excited for people to see this car in person too, because it really is, it takes your breath away the first time you see it.
Yeah.
So, yeah.
Yeah. And we have some comments here saying, sadly, efficiency, until there's an economic incentive in place, to push people towards efficiency, that's going to continue to be a challenge. So there were a couple questions around incentives and, obviously Aptera being an auto cycle, we are working on incentives. We actually have a lobbying team that we're working with at DC. We have a group of our ambassadors who are also supporting our efforts in lobbying. So we are absolutely on the front lines of pushing legislation forward that we hope will benefit, the industry overall, make it easier for companies like Aptera to be able to come to market and be successful, and then also to make it easier for consumers to make those choices that they know are going to be better for the planet. So there's a lot that's happening there that hopefully will drive that that push towards efficiency as well. Okay, well, these are great questions.
Some good questions in here about upgrading the vehicle. If I could touch on that real quick, because that's something that
please. Yeah, and there were some questions around just like repairing. So I was going to add about right to repair. So yeah, please, let's talk about upgrading. Let's talk about what happens if you live in a remote part of the world and you have Aptera and you need a part. How will we make this exceptionally easy for people?
Exceptionally easy. I know it's a big toy car. It's a big plastic toy car. Yes. So right to repair is something that we're very passionate about, right? We see the world going against right to repair, right? And we think that's absolutely the wrong way to go. We think people should be given the ability to upgrade, fix, tinker with, it's their car, right? And what we're seeing as well is that as electric vehicle technology improves, it becomes simpler, and it just gets simpler and simpler and simpler to the point where parts get combined, more parts get combined, and you've really only got 3 or 4 major components for your entire drive system for your vehicle. So it becomes something that, apart from the high voltage aspect, becomes a very easy system to work on. So if you manage the high voltage aspect in a way that is safe, then you can basically allow people to fix their own car, right? Obviously, when we're getting into batteries and stuff, that's a really scary area when we talk about this kind of stuff. But if you want to replace a door latch, or you get a ding on your door, you want to change your door, we don't see any reason why, with basic hand tools, like with, I think it's 3 wrenches and 6 Allen keys, we can take apart the whole car. Then why not give people the ability to work on their own car and make their own changes if they wanted to? This whole COVID thing has really kind of changed the market for why and what we make. And it seems that there's a lot more desire for people to, what they do own, for that thing to be special and to be handmade and to be dedicated to them and custom to them, kind of thing. We want to try and convey that feeling in these vehicles. We want to give people the feeling it's a handmade vehicle, and they had a hand in how it was designed and built for them, right? So we want to just open the door for people to kind of go wild, right? Do whatever they want. Let's have some fun with this thing. So yeah, right to repair is a big one. Obviously, we've got a kind of similar model to Tesla with the roving repair vans kind of thing. Yeah, right to repair is very important for us. Thinking about it now just out loud, the high voltage stuff is kind of scary. That's just thinking about it now. Teslas have some very interesting things, like on the charge plug of their vehicle, we found there's a micro switch on the back that if you take that off, the micro switch disconnects and the whole high voltage system shuts down on the vehicle. So if you tinker with anything on the high voltage, it all shuts down. They've made it very, very safe that we've done some fantastic work on those cars. So we're gonna have to do similar kind of a thing, but yeah. And again, that's how the future is going to be. We learned the other day that Volvo is talking about closing down all of their dealerships. So if car companies start closing down dealerships, this kind of right to repair and service is going to become normal, right? So it's just we're just a bit ahead of our time again, I think. But yeah.
Okay. Well, we have just a couple minutes left, so just a couple questions. I would love to give people an example. There are some questions. Gosh, you guys keep talking about efficiency. Aptera is so efficient. How does that compare? We won't name any names, but how does Aptera compare to other vehicles on the road? How much more efficient is Aptera?
Yeah, well, my favorite one was it's the same drag as the windshield wipers on a pickup truck. Just the windshield wipers. Just those 2 blades is the same drag that we have. So yeah, the net gain in efficiency is extraordinary. It's orders of magnitude. And anybody who's put their hand out of a car window at speed, right, can attest like how much force is on a car at speed. And if you look at the CD numbers of vehicles, where we come in the list with the last vehicle on Wikipedia before you get into like this, into like the speed record cars and the eco car marathon cars, like we're the last one on the production car list on the CD. So we're as efficient as you can get while still having two people packaged safely, like I said, right? So no, it's a paradigm shift. When people realize how efficient this car is and how much energy it doesn't use, yeah.
Okay, great. So just a couple more questions. And I know we have so many questions, guys, between the chat and the Q&A. So we want to make sure we get to them all. If we don't, you can always email us. We'll also take a look at the chat and see if we can reach out to you guys directly. So I apologize if we didn't get to all your questions, but they're awesome. And we're so grateful for all of your participation, making this a great webinar. So last question. What does the future hold for Aptera? So Aptera is our first vehicle. We envision a line of vehicles that are solar efficient vehicles that have, all things in common. They are lightweight. They have, super efficient powertrains, extremely aerodynamic. So what's next? We've got this amazing vehicle that we will bring to market by the end of the year is our goal. But, what do you see? Will there be more seats? Will there, where do we go from here?
No, I know. There's so many options. It's just exciting. The next vehicle is a four-wheeled version, right? So more of a standard kind of a car package, but still using the same, obviously, principles of lightweight and aerodynamics. If you search Aptera online, there's actually a rendering of a four-wheeler that we did. I think Jason Hill did that one 5-10 years ago kind of thing. And it's still a beautiful, beautiful design. And something we could definitely go along the lines of that kind of thing. So we're looking to see how much of this initial vehicle we can carry over into the next one mechanically. We're a big fan of not changing things for the sake of changing things. So if we can have the same parts through all our vehicles and getting the same part means just one part number, then that's what we'll do. But the four-wheeled vehicle is going to be a beautiful challenge, right? Because to package a regular vehicle but use the principles that we have at Aptera, it's going to result in a fantastic vehicle as well. But this one is what's going to set the stage, right? That's what this one is for. It sets the limit of what we can do, and then from here we just keep building on it. So.
That's great. Okay, well, I'm just going to mention a couple last things before we go. Thanks for all the positive feedback. You guys are so nice. I'm glad that you enjoyed the webinar, and I'm glad that we were able to give you some new and exciting things that are happening. We're working really hard. We have a lot going on at Aptera, and we're making a ton of progress. And so we're thankful that you guys can all be along with us as part of this amazing journey that we're all on together. We really do feel like you guys are part of our family. I want to thank all of our ambassadors who work, tirelessly out there, on social media, making sure that the right information is getting out there and, sharing about Aptera. So if you have interest in joining our ambassador program, we would love to have you. You can email us at info@aptera.us. Also, we do have, if your questions didn't get answered, we have a really super detailed FAQ that we can send out later in post. It's an Excel kind of Google sheet, and you can search through it. And so if you didn't get your question answered, I'm pretty sure it's probably on that list. So you guys can take a look at that as well. And also a lot of people asking about investment opportunities. And I know I did mention it at the beginning. We absolutely do intend to be opening up another round of investment over the next couple months. And that will not be on a traditional crowdfunding platform like WeFunder as it was in the past, but it will actually be through our own website. And we will post that on social media. We'll send out emails. I promise you guys will know when that happens. And our intent is that everyone can be able to be a part of that and be a part of the journey of Aptera. And then lastly, we will be posting this on, I think maybe YouTube would be great. We're going to be recording these. And then in the future, these are all going to be integrated into our Aptera website, into our customer area. So you guys can go back and I wondered about aerodynamics. What did Nathan mention that? So you can go back and watch these, and we'll start to have kind of a history of all these. So I hope you like these. We want to give you guys really good stuff. We want to be accessible, and we want to give you as much information as we can and be as transparent as we can. So we appreciate you, Nathan. You're amazing. This guy worked on the space station, and now, of course, it's so fitting that he's an engineer also on Aptera. So we're so thankful to have you, such an amazing talent and so much knowledge. And thank you very much. We appreciate you.
I'm happy to be part of this team, and everybody too. Thank you so much. It was a pleasure, and I'm happy the word's getting out there about this remarkable vehicle and what we're trying to do here. So fantastic.
Okay, thank you, everyone. Have a wonderful day. Take care.
All right, I hope you guys found this interesting. Please don't forget to hit that like and subscribe button. Visit us on Patreon. Thank you so much for watching, and I'll see you next time.